Good morning, everyone. This is Mr. Donato Magarielli from Avio Aero company. It's my great pleasure today to present an illustrative video about the Avio Aero open data included in the turbo machine use case within the Aeronautics large-scale pilot carried out in the EU-funded LEXIS project. The Avio Aero goals in LEXIS are three. First of all, we would like to improve the exploitation of advanced numerical modeling for the CAE simulation of aircraft engines critical parts. Moreover, we aim to speed up hardware-intensive and very time-consuming CFD analysis, exploiting newly designed hardware software components in the GPU-accelerated HPC context. So we are committed to investigate the industrial applicability of last generation HPC cloud and big data platforms through two aeronautical engineering case studies. In the turbo machine use case specifically discussed here, we need to cut the running time of CPU-intensive CFD simulations. From the engineering standpoint, the industrial test case adopted here is a two-stage low-pressure turbine with one big row at the exit, whose airfoils are highly sensitive to low Reynolds number environment, thus worsening turbine overall efficiency. The prediction of the way the turbine is working is a very time-consuming task here, and so the objective is to assess computational time savings in our fluid dynamics simulations by leveraging the hardware acceleration capability provided by GPUs. In the overall application workflow that underlies the turbo machinery case study, there are two critical phases: the application solver execution based on the CFD solver Traff code and the post-processing of the simulation results. These are critical phases because they are computational intensive and so they strongly affect the productivity of Avio Aero engineering department. More specifically, focusing on the application solver execution phase, our main industrial target here is the reduction of Traff running time by at least a factor 5x through the GPU porting of the code. Traff is a CFD solver developed by the research group of Professor Arnone at the University of Florence in Italy, which solves three-dimensional Reynolds averaged Navier-Stokes equations with a special focus on turbo machinery applications. Finite volume discretization on structured grids and dual-time stepping for unsteady simulations are used. The code is parallelized with hybrid MPI OpenMP approach and also ported to GPU, CUDA OpenACC, to fully exploit the modern HPC cluster architectures. The evolution of turbulence kinetic energy contours in a four-stage low-pressure turbine designed using T106 blade profiles is shown in this slide as an example of a time-accurate simulation carried out with the Traff code. Moving back to the assessment of the GPU-enabled release of Traff code, once defined an industrial test case running on only CPU cores as a reference from one side and the minimum number of needed GPUs to accelerate heat on the other side, the performance evaluation for the Traff release with and without acceleration has been carried out on the Barbora cluster at IT for Innovations. The results summarized in the table in terms of adopted HPC resources, CPU cores, parallelization methodology, and measured speedup illustrated that the industrial target in terms of reduction of running time has been successfully achieved through 16 GPUs NVIDIA V100 on Barbora, because the obtained speedup has been 7.04x. However, the execution performance has been further optimized by deploying Traff on the recently introduced HPC Carolina still at IT for Innovations, bringing 21.4x the measured speedup through 32 GPUs NVIDIA A100. In the case of the GPU accelerated solution deployed at Carolina, we can observe that both the number of used CPU cores and adopted GPUs was higher than the ones utilized on Barbora. However, not only from a technical standpoint, but also from a cost perspective, the Carolina solution proved to be more effective than the good one at Barbora. Well, it's time now to conclude this session, so thank all the participants for your interest in watching this video.